Hello students, welcome to Educate. Today we are going to study about power and if you know power is the rate of doing work. So we can say work upon time. Work is also equal to energy. So we can say it is energy upon time. Now we write the units. So energy is measured in joule and time is measured in second. So power has unit joule per second, which is also written as watt. Now there is dot product of force dot velocity, and we will see that this gives power. So let's see how. So power is here, we can write work divided by time, and we know that work is a dot product of force and displacement. So force dot displacement divided by time, and s upon t is velocity. So force dot velocity. Now let's see one question. So we have to find out power. Force is given as 2I cap minus j cap plus 3k cap. And velocity is given, this is in Newton, velocity is given 2I cap plus j cap plus 3k cap. This is meter per second. Now, if we want to find out power, we do dot product. So this vector. So F dot V. So this will give 2 into 2, that is 4 minus 1 plus 9. Do you remember the dot product? I dot I gives 1, J dot J gives 1, K dot K gives 1. So 2 into 2 will be 4. When I is multiplied to J, it gives 0. When I is multiplied to K, it again gives 0. So only I, J, and K coefficient should be written in multiplication. So here 4 minus 1 plus 9, that is 12 watt. I think you have understood. There is another unit of power. So that unit is horsepower. So 1 horsepower is equal to 746 watt. Then 1 kilowatt hour. This is equal to 1 electrical unit of energy. So this is equal to 1 unit. This is also called commercial unit. So it is equal to 1000 watt multiplied by 1 hour. So we can say it is 1000 and this is 3600, and we write the units. Watt is joule per second into second. Second will cancel out and we will get 3.6 into 10 to the power 6 joule. So you have understood. Now there is one question here. The question is, you can read it. An elevator can carry a maximum load of 1800 kg. So load is given 1800 kg and elevator is moving with the speed 2 meter per second, and there is frictional force which is opposing the motion, whose value is 4000 Newton. You have to find out the minimum power delivered by the motor to the elevator in watts as well as in horsepower. So here what you do, just find total force. So total force will be force due to mass here, so that is 1800 into 10 Newton plus frictional force. Frictional force is 4000 Newton. So this will become 22,000 Newton. And velocity is given as 2 meter per second. So velocity is 2 meter per second. So we know that power is force into velocity. So force is 22000 into velocity is 2. So this will become 44,000 and unit will be watt. Now if you want to convert this watt into horsepower. So power in HP is equal to 44000 divided by 746, and it will come out to be around 59 horsepower. So I think you have understood. Now we are going to see different type of collisions. Collisions can be of two types. Number one, elastic collision. Elastic collision means momentum and kinetic energy remain conserved. Another type collision is inelastic collision, in which kinetic energy is not conserved. So here one important aspect we are going to derive, but before that let's see what is happening here. Here there is mass m1 which is moving with velocity u in this direction, and there is another mass m2 which is at rest. Here this is mass m2 and its velocity is, say it is u1 is say u, and u2 is say 0. Now after collision what happens? It may happen that both bodies move in different directions. Suppose this is angle theta 1. So suppose first body moves in this direction with velocity v1, and another body makes angle theta 2 and moves in this direction with velocity v2. So here this type of collision will be two-dimensional collision. Here we will restrict our studies first to one dimension, and after that we will go to two dimensions. So when we talk about one dimension, then what happens? Theta 1 and theta 2 will become 0. So body will travel in straight line. Both bodies will move with certain velocities. So first case we are considering that when collision is inelastic. So what is happening in inelastic collision? So let's see here, as I told you, first body has mass m1 and it is moving with velocity u1. Second body has mass m2 but it is at rest. Now collision happens here, and after that, after collision, the two body moves with certain velocities. But here, since collision is inelastic, so two bodies will stick together and they will move with certain common velocity. Now let's see, is it correct to say that there is a loss in kinetic energy? So initial momentum, if we consider, so initial momentum will be m1 u1 only, because m2 u2 will give 0, and from here it will be m1 plus m2 into v. This is one relation. So if we want to find out what is v, so we can say that v equal to m1 u1 divided by m1 plus m2. Now let's consider kinetic energy. So what is kinetic energy? Before collision it is half m1 u1 square equal to, this will be 0, and here half m1 plus m2 into velocity square. We can put the value of velocity here, but what we are doing, we are equating it. We should not equate. We should check whether this energy, means initial kinetic energy and final kinetic energy, are equal, or initial kinetic energy is greater than final kinetic energy. So for this purpose, what we do, we try to find out the kinetic energy after collision. So Ke before collision, Ke before collision is collision is half m1 u1 square, and k after collision, k after collision. So what will it be? Two bodies are moving together, so 1 by 2 m1 plus m2 times common velocity v square. So we put the values. So here we put 1 by 2 m1 plus m2 times v square. If you square this, what do you get? m1 square u1 square divided by m1 plus m2 whole square. Now, if you further simplify, so this is 1 by 2, 1 m1 plus m2 will cancel out. So you will be left with m1 square u1 square divided by m1 plus m2. So you have got kinetic energy final value. Now we have to check the difference, whether difference is positive or negative. So we take kinetic energy before collision and kinetic energy after collision and just find the difference. So K before collision is, so let's write it as delta K. Here we are evaluating K initial minus K final. That is, K initial is half m1 u1 square minus K final is this much, 1 by 2 m1 u1 square, m1 square u1 square divided by m1 plus m2. Now you have to check the sign of this, whether it is positive or negative. If it is positive, then we will say that there is energy loss. So if we take LCM, we can keep 1 by 2 outside. This will become m1 plus m2 times m1 u1 square minus m1 square u1 square whole divided by m1 plus m2. Now, if we open the bracket, 1 by 2 remains outside, m1 square u1 square plus m1 m2 u1 square minus m1 square u1 square divided by m1 plus m2. These two terms will cancel out and you will be left with 1 upon 2 m1 m2 u1 square divided by m1 plus m2. So this is the relation that we have got, and clearly m1 m2 can't be 0, u1 square can't be 0, which is greater than 0. So you can say that initial kinetic energy is greater than final kinetic energy, hence there is an energy loss. So this was the case of inelastic collision. Now we are going to consider elastic collision. The same case we will consider, and then we will find out the velocity, final velocity and initial velocity, and then we will do certain assumptions. So suppose this is first body, which is whose mass is m1 moving with velocity u1. Second body is m2, which is at rest, and after collision the two bodies, see, m1 moves with velocity v1 and m2 moves with velocity v2. Now if we apply conservation of momentum, what do we get? m1 u1 must be equal to m1 v1 plus m2 v2, or we can write it as, we can take this m1 term together and m2 term we can leave in outside, in right side, and we can, so m1 outside, then u1 minus v1 equal to m2 into v2. Suppose this is equation number 1. Now we write the relation for kinetic energy. So half m1 u1 square will be equal to half m1 v1 square plus half m2 v2 square. Now again we do same thing, but first we multiply each term by 2 so that denominator may get cancelled. Then we take it in this sides, m1 common, u1 square minus v1 square equal to m2 into v2 square. Now this is equation number 2. We can divide equation 2 by equation 1. What do we get? Here a square minus b square applies, so a minus b and a plus b, so a minus b will get cancelled, and here nothing happens, so it will become u1 plus v1 equal to m2, v2 will cancel out, only v2 will be left. So we have got final velocity as v1 plus u1, and suppose we want to find out v2, so we can substitute this value in this equation. So we will get m1 u1 equal to m1 v1 plus m2 times, in place of v2 just write u1 plus v1. Let's simplify. So what do we get? In this case, we will get, our purpose is to get v1, so m1 u1 equal to m1 v1 plus m2, this is u1 plus m2 v1. So we can do one thing, our purpose is to get v1, so we take m1 u1 term and m2 u1 term to LHS. So m1 u1 minus m2 u1 equal to, here we can take outside v1, then m1 plus m2 will be left. Now our concern is to get v1, so v1 will be equal to, here what is common, u1 is common, m1 minus m2 divided by m1 plus m2. So we have got two relations. One is this one, u1 plus v1. Let's write them together and then we will try to interpret the various situations. So here we have v2 equal to u1 plus v1 and v1 equal to u1 times m1 minus m2 divided by m1 plus m2. Now what can we conclude from here? Here we can imagine different situations in terms of masses. Suppose masses are equal, then what will happen? If masses are equal, then this term will become 0. It means v1 means first body will come to rest. Another situation, if m1 is very large as compared to m2, so we can neglect m2, and there is no other case in your syllabus now, so you just understand up to here. Earlier in syllabus different situations were there, but now it is removed from your syllabus. But here I would like to tell one more case when second body is not at rest. In that case, suppose you have to find out the relative velocities. So there is an important relation. The relation is relative velocity of approach equal to relative velocity of separation. So let's try to derive that concept also. That is also one important concept. So here we are taking that two bodies are moving. First body M1 is moving with velocity u1, another body m2 is moving with velocity u2, and they collide, and after collision they start moving with velocity. This m1 is moving with v1 and m2 is moving with v2. Now we are assuming that collision is elastic, so kinetic energy and momentum both remain conserved. So we can say that m1 u1 plus m2 u2 must be equal to m1 v1 plus m2 v2. Now take m1 terms in LHS, so you write m1 and then u1 minus v1 is equal to, here it is m2 then v2 minus v1. Equation number 1. And we consider kinetic energy. So 1 by 2 m1 v u1 square plus 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Now multiply each term by 2 and then shift m1 v1 square to LHS and m2 u2 square to RHS. So what do you get? m1 u1 square minus m1 v1 square is equal to m2 u2 m2 v2 square minus m2 u2 square. Now m1 can be taken out and you will get u1 square minus v1 square is equal to m2 can be taken out, v2 square minus u2 square. Now this is equation number 2. If you divide equation 2 by equation 1, what do you get? Here u1 square minus v1 square will become u1 minus v1 and u1 plus v1. Other terms will get cancelled out. So here you will get u1 plus v1, and here if you divide this, so m2 will cancel out. Here v2 minus u2 and v2 plus u2, so v2 minus u2 will cancel out. So you will get v2 plus, this is v2 plus u2. Now do one thing, shift this u2 to LHS, v2 this v1 to LHS. So u1 minus u2 is equal to v2 minus v1. If you notice, u1 minus u2 is relative velocity of approach and v2 minus v1 is relative velocity of separation. So you can conclude that in case of elastic collision, relative velocity of approach is equal to relative velocity of separation. I think you have understood. Now, here there is one question. Let's see what does this question say. Slowing down of neutrons. In a nuclear reactor, a neutron of a high speed, typically 10 power 7 meter per second, must be slowed to 10 power 3 meter per second so that it can have a high probability of interacting with isotope uranium-235 and causing it to fission, so that a neutron can lose most of its kinetic energy in an elastic collision with a light nuclei like deuterium or carbon, which has a mass of only a few times the neutron mass. The material making up the light nuclei, usually heavy water D2O or graphite, is called a moderator. So let's see. Here you have understood what they want, so let's analyze it, what is happening. So first of all, you should know what is nuclear fission. So what happens, suppose this is nucleus which contains certain number of protons and neutrons, and there is nuclear force which binds these protons and neutrons, and hence net force means there will be more, a lot of protons will also be there on the basis of atomic number. So like suppose you consider uranium, say it, you know, atomic number of uranium is 92. In our question it is given 92 and 235. So here protons are 92 and neutrons will be 235 minus 92, 143. Now what happens? Inside there are protons, they will repel each other, but there is nuclear force which will dominate, and that is always of positive nature. But there is always delicate balance here. If a neutron enters in the nucleus, suppose one neutron is entering, in that case what happens? This the two type of forces are there, as I told you. One is nuclear force, which is positive, sorry, you can say which is always attractive. So that binds all protons, all neutrons together. But there is also electrostatic force, since protons will repel each other. But the situation in general is that nuclear force dominates the electrostatic force. So nuclear force is greater than electrostatic repulsion force. Now what happens when a neutron enters? Then this delicacy is imbalanced, means there is disturbance, and then electrostatic force dominates the nuclear force, and hence nuclear fission takes place. Nuclear fission means nucleus breaks into two daughter nuclei. So that you will study in next level. But the concept is this. So here, if neutrons are moving with faster speed, in that case they will not collide, they may escape. So in order to make them collide, it is necessary that they must be slowed down. So for this purpose, suppose this neutron is going in its path, some nuclei are kept like heavy water. Heavy water is deuterium oxide D2O. Then what will it do? It will take certain energy of neutron, and then neutron will start moving slowly, and hence it will collide with the nucleus and nuclear reaction will take place. So question says the same thing. Once again, I am reading the question and then we will try to analyze what is happening. So here, slowing down of neutron. In a nuclear reactor, a neutron of high speed, typically 10 power 7 meter per second, must be slowed to 10 power 3 meter per second, so that it can have a high probability of interacting with isotope this and causing it to fission, so that a neutron can lose most of its kinetic energy in an elastic collision with a light nuclei like deuterium or carbon, which has a mass of only a few times the neutron mass. The material making up of the light nuclei, usually heavy water or graphite, is called a moderator. So I think you have understood the question. So we are going to see what energy neutron possesses, and when it collides with some other neutron, then what energy it has. So as we have seen in the derivation of inelastic collision, that final kinetic energy is less than initial kinetic energy. So here initial kinetic energy K initial will be that of neutron, so that is half, and mass of neutron, say we write mn, and suppose it is moving with velocity v, say you can say v, or you can write it u, that will be better. So this is u square. So this is kinetic energy of neutron. Now it combines with, it collides with any particle, then its final kinetic energy, say kf, will be equal to, as we have derived, that its final kinetic energy will be 1 by 2 times mass of neutron. Then here inside, mass of neutron minus mass of another particle. So suppose we take it as m2, second particle, divided by m1. m1 is mass of neutron plus m2. And then velocity will be initial velocity square, same velocity will be there, u square. So here obviously there is energy loss. So we have to find out what is the fractional energy loss. So we can find the ratio of to kf divided by ki. So it is simple, you can put these values, so you will get a fraction, and here I have left something, it was square. So what do we get then? So we will get n minus m2. m2 is any nuclei that is preventing, or it is acting as moderator, and this is m1 mn plus m2 and whole square. So this will be the case, because u square will cancel out, mn will cancel out, half will cancel out, so we have got this ratio. Now suppose you are given that mass of nuclei, second one is given, if we are taking as deuterium, so we can write mass of deuterium, and we can take the value of mass of neutron, and then we can evaluate. So we will get a certain relation, but here information is not given, so you have to restrict yourself till here. We are not going ahead. Later on we will do some numericals based on it, then thing will become clear. Now we are going to proceed with other concepts. So next concept is collision in 2 dimensions. So here, to consider collision in 2 dimensions, as I told you that suppose there is one object which is moving with velocity u, and there is another object which is either at rest or in motion, but here we are assuming it that it is at rest. This is m1, this is m2, and it is at rest. So if we write it u1, so u2 will be 0. Now after collision, what happens? One object moves in this direction with angle theta 1, and another object will move in this direction with angle theta 2. Suppose here this is m1 which is moving with velocity v1, this is m2 which is moving with velocity v2. Now again we apply the conservation of energy, conservation of momentum. So what do we get if we apply conservation of momentum? So we can say along x-axis momentum remains constant, along y-axis momentum remains constant, because here we are considering 2-dimensional situation. So along x-axis we have to take components of momentum for this, so it will become m1 v1 cos theta 1, and for this if you take, it will be m2 v2 cos theta 2, and here, so we can say momentum conservation. So it will become m1 u1 equal to, only components along x-axis should be considered. So m1 v1 cos theta 1 plus m2 v2 cos theta 2. This is equation number 1. And now momentum along y-axis, here momentum along x-axis is given, but momentum along y-axis is 0. So we can say the component that we get after collision, so that is m1 v1 sine theta, component upward, because here in this direction, and here they must be equal and opposite. So minus, this is m2 v2, this is sine theta 1, sine theta 2 must be equal to 0. Here we are considering the direction. One is upward, positive, this is negative. Or you can say m1 v1 sine theta 1 must be equal to m2 v2 sine theta 2. Correct. And if you consider kinetic energy, initial kinetic energy, so what is kinetic energy here? So it does not matter, even after taking components and squaring, we will get same result. So we can say in case of kinetic energy, so initial kinetic energy 1 by 2 m1 u1 square must be equal to 1 by 2 m1, and then v1 square plus 1 by 2 m2 v2 square, with components again cos square theta plus sine square theta will give 1, hence answer will remain same. So you have understood this concept also. Then next thing comes, there is one numerical here. Let's see this. Consider the collision depicted in figure 5.10. The same situation as I told you in two-dimensional motions. One, they are talking about this type thing, that one is this, one is this is theta 1, this is theta 2, and here m1, this is v1, this is m2, and moving with velocity v2. And what is happening here, there was particle with m2 and with velocity u2 as 0, and another particle was moving with velocity m1, sorry, mass m1 and with velocity u1, and after collision they moved like this. Now question says, consider the collision depicted in figure 5.10 to be between two billiard balls with equal masses. m1 equal to m2 is given. The first ball is called the cue, while the second ball is called the target. The billiard player wants to sink the target ball in a corner pocket which is at an angle of theta 2 equal to 37 degree. Assume that the collision is elastic and the friction and the rotational motions are not important. Obtain theta 1. So here, if you remember, we have derived the relation earlier. The relation was initial velocity, first ball was moving with velocity u and second ball was at rest. So after applying momentum conservation principle, we get u equal to v1 plus v2. And in terms of kinetic energy, if we write, so here we write v1 square, we can write it as v1 dot v1, and then we put the value of, sorry, better to write, we are taking in terms of u, so kinetic energy will be, initial kinetic energy will be half m u square, and when we have divided we got this. So we are considering that its energy. So here first of all we have to find out u square. So if you consider u square in order to get this kinetic energy, so u square we can split like u vector dot u vector, and u we consider this, so we can write, if you write it in vector term, so it will be the v1 plus v2 dot v1 plus v2. Now if you remember dot product, so vector a dot vector a gives a square, vector a dot vector b gives ab cos theta. The same thing will happen here it will become v1 square plus v2 square plus twice of v1 v2 cos theta, where theta is the angle between the two velocities. The situation is like this. Here this is theta 1, this is theta 2. So here theta will be sum of the two, theta 1 plus theta 2. Now here our question says that you have to find out theta 1. So what is situation? So let's see. So our relation that we have got, so that is u square is v1 square plus v2 square plus twice of v1 v2 cos theta, where theta, here two angles are there, one is theta 1, another is theta 2. So in our question this is to be found, and this is given as 37 degree. So here in place of cos theta, what we can write? U square equal to v1 square plus v2 square plus twice of v1 v2 cos of theta plus 37 degree. Now if we consider kinetic energy, so what is case of kinetic energy? So relation 1 by 2 m, here both masses are same, so we will get the relation 1 by 2 m will cancel out, 1 by 2 m. If we write u square equal to 1 by 2 m v1 square plus 1 by 2 m v2 square. So what happens? 1 by 2 m will cancel out, so u square will be v1 square plus v2 square. Here what relation we have got? We have got u square equal to v1 square plus v2 square plus 2 v1 v2 cos theta plus 9 theta plus 37 degree. And if we put this value of u square here, so this will become v1 square plus v2 square equal to v1 square plus v2 square plus twice of v1 v2 cos theta plus 37 degree. Now these two terms will cancel out, so we will be left with cos theta, this term equal to 0, twice of v1 v2 cos theta plus 37 equal to 0. Since v1 and v2 are not 0, so this term must be 0. So for that it is necessary that this theta plus 37 must be 90, because cos 90 is 0. So theta plus 37 is 90, from where we can get theta equal to, is it 53 degree? Yes. So we have got the answer. Thank you for watching. Team Educate.